Alright, in this video I'm going to talk about the most important temperature scales for science, and that is Celsius and Kelvin. You need to know how to convert back and forth between the two of them, and it's actually pretty simple. This formula is on your equation chart, but it's simply that the temperature in Kelvin is equal to the Celsius temperature plus 273. So all you need to do to convert from one to the other is either add 273 or subtract 273. If you have Kelvin temperature and you want Celsius, you can subtract 273. If you have the Celsius temperature and you want Kelvin, you just add 273. These temperature scales are interesting. Fahrenheit is obviously the one that we use in the United States, and it's the most frustrating, it's the most abstract, arbitrary, stupid temperature scale that we have, and we just do that because it's tradition. We've done that before. But if you look at the boiling points and freezing points between Fahrenheit and Celsius, I think we know that the boiling point, or the freezing point rather, of water, for instance, these temperature scales are all for water. Freezing point for water is 32 for Fahrenheit, and hopefully you remember that the boiling point is 212. And in Celsius, that's 0 and 100. Okay, so hopefully you can see right off the bat that between Celsius and Fahrenheit, there are two major differences. Number one, obviously, that we have different numbers for the two different scales, and I think that's pretty obvious, pretty self-explanatory and understandable. But the other difference is this. If you look at how many degrees exist between 32 and 212, you have about 180 degrees. That's the distance, I guess you can say, the distance in heat in degrees from here to there. Versus from 0 to 100, we have only 100 degrees in between. And this reveals the most important difference, and that is that they are different scales entirely. Not only do they have different numbers, but between 1 degree and the next, for Fahrenheit, it doesn't represent the same amount of heat added or taken away as from 1 degree to the next in Celsius. In Celsius, the distance from 1 degree to the next is much greater, and that's the reason why if you go to the UK or somewhere like that and they say that the temperature on a typical day will increase from 25 to 35 degrees, you might think, because we live in the United States, you might think that's not a very big increase, when in fact it is. A 10 degree increase in Celsius is almost a 20 degree increase in Fahrenheit. It's almost double. So those are the two main differences between those scales, and you can go through. You have this page. It's on the website. You can go through those and do those on your own to practice converting from Celsius to Kelvin. But again, if the temperature is 0 degrees Celsius, I would simply put 0 in here, and I want to solve for Kelvin. So 0 plus 273 would be 273 Kelvin. All right. So that brings us to the next scale, which is Kelvin. The Kelvin scale, the freezing point is, well, we need to actually put another point down here at the bottom, and that's absolute 0. Absolute 0. I'm not concerned about where absolute 0 is for Fahrenheit, but for Celsius, absolute 0 is negative 273. Whereas absolute 0 for Kelvin is 0 itself. Freezing point for Kelvin would be 273 degrees, and boiling point for Kelvin will be 373 degrees. Alright, so the differences between these two scales, as opposed to Fahrenheit and Celsius, we again have different numbers. But if you'll notice the distance from the freezing point to the boiling point, for instance, it's still 100. And so the unique thing about Kelvin and Celsius is that while they're different numbers, they're actually the same scale. The distance from 1 degree to the next in Celsius is the same distance from 1 degree to the next in Kelvin. It's just that they're different numbers. Kelvin is jacked up about 273 degrees. And the reason for that is that the Celsius scale is based on water. It didn't just so happen that the 0 is the freezing point of water. Whoever invented the Celsius scale, Mr. Celsius, he decided it should be that way. He decided that 0 should be the boiling point, or 0 the freezing point, 100 the boiling point. This is based on water. It's arbitrary. The Kelvin scale is not based on water. The Kelvin scale is based on absolute 0. Lord Kelvin decided that the Kelvin scale should represent kinetic energy of the molecules, which I'll talk about in a second, and he decided that the 0 point should be the absolute lowest temperature you can possibly get to. So that's what the Kelvin scale represents. All right, and we need to talk about temperature itself. I want to start out with this number 7. What do thermometers really tell us about molecules and kinetic energy? Well, temperature is really a measure of the average kinetic energy of a molecule. Because what happens in any particular substance is that the molecules themselves are not still. They're actually moving around. They're vibrating. All right? They're vibrating. And when you heat a substance, what happens is that those molecules actually move faster, which means their kinetic energy is increased. And so what you can do is effectively take all the kinetic energy of all those molecules and kind of get an average to say, okay, one molecule has this amount of kinetic energy, and that's what it would be. Temperature is not a measure of heat. And that's very important to remember. Temperature is not a measure of heat. For instance, if I have a cup of water that's 90 degrees Celsius and I put a thermometer in, it's going to read 90 degrees. And if I have a bucket of water that is 90 degrees Celsius and I put a thermometer in, it's going to read 90 degrees. So I'll just use this part. Here's my cup, here's my bucket, both of them at 90 degrees. And if I ask you which one has more energy, it might be tempting to say, well, they both have the same energy, but that's not true. Because quite obviously, this bucket has greater mass. And for a reason that we'll talk about soon, since it has greater mass, it contains more heat energy. There's more quantity of energy inside that bucket of water than in this cup of water, even though they're the same temperature. And the reason is because the temperature expresses the average kinetic energy of any particular molecule in that substance, how fast any one molecule would be moving. It is not a measure of heat energy. And that brings us to the second point, which is that there can be no temperature below absolute zero, because absolute zero is where there is no more kinetic energy. In other words, at absolute zero, you cool it down, you cool it down, you cool it down, and then absolute zero comes and the molecules actually stop moving. That's the only time when the molecules actually have no more kinetic energy. They're so cold that they're not moving. And that's the reason why Lord Kelvin wanted this to be zero, because that represents that there's no kinetic energy. The reason why, therefore, that you can't have any temperature below absolute zero is because you can't go any slower than stopped. When these molecules have no kinetic energy, it's impossible to take any more energy out of that molecule, out of that substance, because there is no thermal energy inside the substance. So that's a little primer on temperature. You need to know the Celsius and Kelvin scale, most importantly, and how to convert between the two. And you need to understand what temperature is and the difference between temperature and heat. That temperature is not a measure of heat, not a measure of heat energy. And the reason why that there's no temperature below absolute zero is because that's when there's no kinetic energy and you can't go any lower than that.